The Olympics is a world-renowned sporting event where athletes represent their country in various sports. The first ever Olympics took place in Athens in 1896, consisting of 9 events. The most recent 2016 Olympics took place in Rio, consisting of 309 events. The purpose of this report is to determine if certain factors affect the outcome of how countries do when competing for medals at the Olympics. There were 4 variables used to conduct this study. Number 1 was the amount of medals won at the 2016 Rio Olympics. Number 2 was the country's population. Number 3 was the amount of medals won at the previous Olympic Games, which was the 2012 London Olympics. And number 4, which is the country's gross domestic product, which is the GDP. All this data was collected from online sources and are relevant to the present year, other than the 2012 Olympics, which was taken from that year. I hypothesize that all variables will have a positive effect on the outcome of how many medals each country gets at the Olympics, some more than others. The country's GDP will have the largest effect, followed by the population, and ending with the number of medals won at previous Olympic Games, which will have the lowest effect. For my one variable statistic analysis, I will be analyzing the central tendencies and measures of spread for each of the graphs. The central tendencies include the mean, the average of the data set, the median, the middle point of the dataset, and the mode, the most frequent occurring value in the dataset. The measures of spread include standard deviation, the average distance between the data points, and IQR, which is the interquartile range. In this set of data, the mean, average number of medals won, is 34.5. The median, the center of numerical dataset, is 21.5, and the mode, the most reoccurring number, is 15, 17, 18, 19, and 42, all of which repeat twice. The standard deviation, the dispersion of data, for this set is 26.83, and the IQR, the middle spread of data, is 24.5. Of this data, there are 2 noticeable outliers, one of which has a frequency of 10 and amount of medals between 110 and 130. The mean, the average population of country, in this set of data is 1.38. The median is 5.35. There is no mode for this set. The standard deviation of this data is 3.03. Because the digits are so high, I could not calculate the IQR in an accurate way, although there is a significant outlier in the data where one country has a population between 1,300 and 1,400. In this set of data for London medals, the mean, average amount of medals won, is 34.6. The median, which is the center of the numerical data, is 24, and the mode, which is the most reoccurring number, is 13, 17, 18, and 28, all of which repeat twice. The standard deviation, dispersion of data, is 28.25, and the IQR, the middle spread of data, is 26. There are a little to no outliers in this data. For the GDP, the mean is 2,762.71. The median, the center of the numerical data, is 1,336.07. There is no mode, which is the repeating numbers. The standard deviation, which is dispersion of data, is 4,506.47. The IQR, which is the middle spread of data, is 2,328.125. There are 2 outliers shown on the graphs, one standing between 11 and 12,000 GDP and the other between 18 and 19,000. For the 2 variable statistic analysis, I will be comparing the variables and analyzing the linear regression, determining if there is any correlation that proves my hypotheses. Comparing the Rio medals to population, the correlation coefficient is 0.491. This is a weak positive correlation. Although because there is a positive correlation, it shows that the population of a country does indeed affect the number of medals they won at the Rio Olympics. It is a weak correlation, although still affecting the outcome. Comparing Rio medals to London medals, the correlation coefficient is 0.945. This is a strong positive correlation, exemplifying that medals won at the 2012 London Olympics does in fact affect the number of medals won at the Rio Olympics. When comparing Rio medals and countries' GDP, the correlation coefficient is 0.899. This is a strong positive correlation, which tells me that the GDP of a country has a positive effect on the amount of medals won at the Rio Games. Although my inference of the order of variables from strongly affecting to least was wrong, my hypothesis was still indeed correct. Each variable positively correlates and affects the outcome of countries at the Rio Olympic Games. The correct order of correlation due to strength was 1. The medals won at previous Olympic Games, 2. Country's GDP, followed by 3. Country's population. As the Olympics is a reoccurring sporting event, it would be interesting to see if in years to come, analyzing the same but up-to-date data would result in the same answer, that population, medals won at previous years, and GDP would all play a role in the success of a country at the Games. Looking at specific sporting events or athletes could be the next step for determining further research in this topic.